The dmc150 spectroradiometer has been removed from the EnviroBox for the purposes of explaining some of the features of this unit. It is composed of a dmc150 compact double monochromator, a multi-alkali PMT detector, MDE detection electronics, has fiber input for the measurement of solar irradiance, or additional accessories for the characterization of radiometers. The dmc150 monochromator is composed of two component halves, two 150mm monochromators in additive dispersion mode to yield a 300mm focal length double monochromator. Light entering the entrance port is relayed through 45 degrees by a plane mirror and is impinged upon a spherical mirror of 150mm focal length. The distance between the mirror and the entrance slit is 150mm, and therefore light issued from the mirror is collimated. And it's collimated onto a diffraction grating, on which diffraction obtains and interference results. Light is collected by a second spherical mirror and is transmitted through a middle unchangeable slit to the second component monochromator, in which the same process occurs. We have a spherical mirror, diffraction grating, spherical mirror, and a plane mirror coupling light either to the exit port with a photomultiplier or the exit port in which the RSR unit is placed for the characterization of radiometers. And this mirror is mounted on a solenoid, a swing-away mirror, which can be controlled through a computer. The bandwidth of the system is defined by the largest of the entrance or exit slits. One can think quite clearly in the description of how this can be defined by the exit slit, in that given that having obtained dispersion and the input light is dispersed to its component wavelengths, one can effectively consider the exit slit as the wavelength scale. The larger the slit, the more wavelengths one samples at a time. With regards to the impact of the entrance slit on bandwidth, one simply needs to consider that the monochromator is an imaging optical device, and in fact what is present at the exit slit is an image of the entrance slit in all of the colours, or all of the wavelengths. Therefore, a large entrance slit will equally have an impact on bandwidth as a large exit slit. In practice, we tend to use a system with equal entrance and exit slits. The middle slit is not changeable. The system is provided with slits for 1, 2 and 5 nanometer bandwidth, and at the exit of the port for the radiometer mode we have a 1.5 by 5 millimeter rectangle. Behind the entrance port is placed an order sorting filter wheel, a 6-position filter wheel which provides a shutter. It has a clear, an open position for measurements up to 400 nanometers. From 400 nanometers, the OS400 long pass filter is fitted to suppress higher diffraction orders, and at 700 nanometers, a second filter, the OS700 long pass filter, is installed. The diffraction gratings fitted are mounted on kinematic mounts and are driven in tandem. The diffraction gratings are 1800 groove per millimeters, giving the spectral range of the device around 200 to 800 nanometers. The detector used in the solar irradiance mode is the DH3 multi-alkali S20 photocathode photomultiplier, which gives very, very high sensitivity in the range 200 to around 850 nanometers. This device requires a high voltage for operation, provided by a high voltage supply in the MDE electronics. connected via a thick BNC cable, and there is an on-off switch with a green LED indicator beside it. The signal from the photomultiplier is connected to input 1 next to the high voltage input via BNC to SMA connector cable. The BNC cable is simply connected directly. The SMA connector is pushed on and rotated to ensure it's firmly in place. To the base of the unit is provided a transimpedance amplifier with 2 inputs, which detects the signal from the photomultiplier and provides a reading to the computer through an A to D converter. When used in radiometer mode, one must remove the cable connecting the signal of the photomultiplier to input 1, and one will use input 1 for the reference diode or the device under test through the 472 unit, and input 2 for the monitor photodiode. This unit has 1 mains input and 1 USB input found to the rear, and beside the photomultiplier a 3-pin connector is provided, which leads to a thermocouple on the unit to monitor the temperature in the EnviroBox for the purposes of the EnviroBox controller.